fraction that you want to practice. In little pieces of it is so important. Just take little chunks at a time. So, a complex rational expression, otherwise known as complex fractions, are rational expressions whose numerator, denominator, or both contain one or more rational expressions. There are two methods that can be used when simplifying complex fractions. So what we're talking about for a complex fraction, what that means is you have a rational expression in the numerator, and you have, or the denominator, okay? So you can have them in both. Okay, so this is what a complex rational expression or a complex fraction looks like. So you've got a fraction or a rational expression in the numerator and or denominator. So in order to simplify those, we've got to get rid of that. We've got to eliminate the fractions, and then we have to divide the two together. So let's talk about two different ways that we can do this. There's two different ways. Simplifying complex fractions. Method 1. Simplify the numerator and the denominator of the complex fraction so that each is a single fraction. Okay? So you're going to focus on the numerator, simplify whatever you need to in the numerator, then you're going to focus on the denominator and simplify whatever you need to in the denominator. Number 2, perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. Okay, so we're going to simplify the numerator, simplify the denominator, and then we're going to divide the two, which we already know how to do. Okay, then we'll look at it again and see if we need to simplify. So let's do one of these. I have x over 2 plus 2. X over 2 plus 2 over x over 2 minus 2. What we're going to do is we are going to look at this numerator right here, and we are only going to focus on that numerator. So we are going to simplify this, and we learned how to do that on Tuesday. So we know how to combine these two right here. So that's what I'm going to focus on first. That's what I'm going to focus on first. So I have x plus 2 plus 2 over 1. X plus 2 plus 2 over 1. So I need to find my LCD. Okay, I need to find my LCD. What is my LCD between 2 and 1? 2. Okay, it's my LCD. Now, this denominator already has a 2 in it. So I don't need to do anything to this fraction. I don't need to do anything to it. What is missing from this denominator right here? Good. If I multiply the bottom by 2, what do I have to do to the top? Good. Okay, so then I'm left with x plus 4 over 2. So what I have done right there is I have simplified the numerator. Okay, so I combined these two things right here and got this. Now what we're going to do is the same thing with the denominator. Okay, so I have x plus 2 minus 2 over 1. Okay, what's the LCD here? 2. Okay, this already has the 2, so I don't need to do anything to that. The second one, what do I need to do? Good. So if I multiply the denominator by 2, I have to multiply the numerator by 2. Okay, so then I've got x minus 4 over 2. Okay. So what I have done is I simplified this numerator using the techniques that we learned on Tuesday. Then I simplified this denominator using the techniques that we learned on Tuesday. Now what I have is division of rational expressions. And do we know how to do that? Yes. We rewrite it. Change the sign. And multiply by the reciprocal. And I'm going to give you 1 minute to do that. 1 minute to do that. So you are doing that now. And what we're doing right now is what the quiz is over. You do. Just over simplifying and all that, not over addition and subtraction. Or what we do today. Just simplifying, multiplying, and dividing. Okay. So what I did first was I rewrote this as horizontal. So x plus 4 over 2 divided by x minus 4 over 2. Then I changed it using keep, change, flip. So I kept this right here, changed division to multiplication, and multiplied by the reciprocal. At this point, these cancel, and we are left with x plus 4, x minus 4. And that is our final answer. Right here. Okay, a lot of students use this method. Okay? Another method, is it okay if I move off this page? This is the method that I think is the most straightforward and the most beneficial. You can use either method. But this one has less steps. There's less steps involved. Simplifying the complex fraction method 2. Multiply the numerator and the denominator of the complex fraction by the LCD of the fractions in both the numerator and the denominator. So we are just going to look and we are going to identify the LCD of the entire problem. Okay? And then we're going to multiply everything in that problem by this LCD, and then we're going to simplify. Okay? So that is method 2. Okay. So let's look at what we've got here. Okay? I have 4 denominators that I need to look at. 4 denominators. So I'm going to look at y squared, 3, y, and 6. Those are the 4 denominators. I need to find the LCD of all 4 of those. So what I'm going to do is I'm going to break each one into primes. So I have y squared. That's just going to be y times y. Okay, and then I have 3. Can 3 break down anymore? No. Okay, then I have y. Can y break down anymore? Nope. And then I have 6. What does that break down to? 2 and 3. Okay. So the first thing that I'm going to do is I'm going to look for things that repeat. I'm going to start looking for things that repeat. So I have a y here and a y here. So I'm just going to write that down one time. It's okay that they don't repeat in everything. If it did repeat in everything, then you would write it down as well. But we're just looking for things that repeat. What else repeats? 3 and 3. Okay, so we've got the 3 and the 3 that repeat. So I'm going to write that down one time. Now what's left over? A 2 and another y. Okay, so my LCD is going to be 6y squared. Now, if you wanted to leave that factored as 2 times 3 times y, that's okay too. Because if you're dealing with binomials, I definitely would keep the binomials factored. I wouldn't multiply those out. Because this is what we call a monomial, which means one term. You could multiply it out. It's really up to you. Now what I'm going to do is I'm going to take this LCD and I'm going to multiply everything by it. Okay? So I'm going to multiply everything in the numerator by 6y squared over 1, and then I'm going to multiply everything in the denominator by 6y squared over 1.
Why is it over 1?
Because you can write anything over 1. So what we're going to do right here is we're going to distribute this 6y squared, and I just want you to realize that we're not multiplying the denominator by anything. We're only multiplying the numerator by that.
Why?
What? So if we went back to this problem right here, well, actually even this problem, well, where is it? Oh, this one. Well, I erased it. When I was working the top off to the side, I put this over 1 and this over 1 to keep it straight, that everything here had a numerator and a denominator. So I'm really writing this right here to keep it straight, that 6y squared over 1 is what I'm multiplying by, because this has a denominator and this has a denominator. Now, some people don't write the 1, and that's okay.
Okay.
Yeah, I understand. You kind of got to process it for a second. Yeah. Okay, so now I'm going to multiply. So what I have is I have 6y squared over 1, and I'm going to multiply that times 1 over y squared. Okay, so the y squared is right here. That's part of my original problem, the 1 over y squared. The red is what I am multiplying everything by. So now I've got 6y squared over 1 times 2/3. Okay? Okay, now we're going to do the same thing in the denominator. I have 6y squared over 1, and I'm going to multiply that times my 1 over y. Then I have 6y squared over 1 times 5 over 6. Now, look at my 6y squared in red. That is my LCD, and that is what I am multiplying everything by, is that 6y squared. Now look at what's in purple. Everything in purple is my original problem. It's my original problem. Okay? This seems like a big, clunky step. Takes up a lot of space. But look what happens. I've got y squared here, and I've got y squared here, so they cancel out. Here I've got a 3. 3 goes into 6 how many times? 2. Yeah, so I'm going to have a 2 right there. Here I've got a y, so y squared is going to get simplified down to y. And then I've got 6 and 6. What has been eliminated? What has been eliminated? Everything that's in what? What part of the fraction is this right here? The denominator. And in every one of these denominators, what do I now have? A 1. So by multiplying everything by the LCD, I now have a 1 in all of my denominators, and I have gotten rid of the complex part of the complex rational. Okay? So that's what's happened right here. So now I can rewrite this as 6 plus 4y squared. Okay, so here's my 6, and I multiplied that times 1. Here I've got 2y squared times 2. That's how I get my 4y squared. Okay, what's going to be left right here? Good, 6y. And then here, what do I have left? Excellent, 5y squared. Okay, now I have one more step, and it would be to see if I can factor anything out. What could I factor out in the numerator, which is the top? What can I factor out? A 2. What can I factor out in the bottom? Y. Can those cancel? A 2 and a Y? Can they cancel out? No. So you can leave your answer just like this right here. Okay? So that is acceptable. If you wrote 2 times 3 plus 2y squared, or y times 6y minus, 6 minus 5y, that's okay as well. But this right here is what's considered your final answer. These take practice. These take practice and lots of practice. Okay? Can we do another one? Okay. So I've got x plus 1 in the numerator over y. So that's my numerator of my complex fraction. Then I've got x over y plus 2. Okay. So I like to go ahead and write this 2 over 1. So now I'm going to look at my denominators. I have y, y, and 1. So what's my LCD? Nope. Doesn't have to be squared. Just y. Yeah. The only reason it would be y squared is if one of those was y squared. Okay? Okay. So now what I'm going to do is I'm going to multiply everything times y over 1. Okay, I'm going to multiply everything times y over 1. Now, I want you to watch how I write this right here, because remember, this binomial is together. It's got to stay together. So I'm going to write this as y over 1 times this rational. That's x plus 1 over y. Okay? Don't distribute this y because we're about to just cancel it out. Okay? It's not wrong to distribute it, but as soon as you distribute it, you're going to have to factor it out. Okay? Now what we're going to do is the denominator. So I have y over 1 times x over y plus y over 1 times 2 over 1. Okay? So now we clean it up. Okay? What am I left with right here? Excellent. X plus 1. And what are we left down here? Excellent. X plus 2y. Good job. Okay, can I simplify anything? No. So that is my final answer right there. Okay. Can I go to the next one? Okay. Now what we're going to focus on is we're going to look at negative exponents. So we're going to have rationals where we have negative exponents. So one of the things that we have to do is we have to remember what is it that a negative exponent means. What is it that a negative exponent means? So if I have x to the negative 3, what does x to the negative 3 mean? Think way back. It's not negative 1.
It's 1 over x third.
You got it. That's exactly what it means. It's 1 over x to the third. Okay? 1 over x to the third. Okay? So that's what a negative exponent means. So we have to be careful with that, because that's the first thing that we're going to have to do with these types of problems is we are going to have to rewrite them. We're going to have to rewrite them. Okay? When you have a rational expression where some of the variables have negative exponents, rewrite the expressions using positive exponents. The resulting expression is a complex fraction, so use either method to simplify the expression. Okay, so the first thing that you've got to do when you see these is you have to rewrite it. That's the first thing that you have to do is do a rewrite. Okay? So, we are going to focus on the numerator here first. We're focusing on this numerator. What is happening between x to the negative second and y to the negative second? What operation? Excellent, multiplication. So when I rewrite this, I'm going to have 1 over x squared times y squared. So that is just one fraction. Now you could write it as 1 over x squared times 1 over y squared. Okay, you could write it like that. But then it's multiplication, so we can just combine. Okay? Here, though, what is happening between these two? Addition. So we have to rewrite this as two different fractions. Here it's one fraction because of the multiplication. There, it's two fractions because we're adding. Now, here, what's being raised to the negative 1? Just the x. The 5 is not. So where does the 5 stay? Good. So I'm going to have 5 over x. Okay. What's being raised to the negative 1? Good. So here I'm going to have 2 over y. Okay. Now I'm going to identify my exponents, or my denominators. So this is one denominator together. Then I have x, and then I have y. Okay? So let's look at this from my LCD perspective. LCD. So I have x squared times y squared. That means x times y times y. Okay? Then I have an x, and then I have a y. Okay? Here I've got an x that's common to both. So for my LCD, I only have to write that down once because it shows up in two places. The same thing happens with my y. I have a y common to two places. So I'm going to write that down one time. These are left over, so I have to include those. They haven't been accounted for yet. Your LCD is always going to have your highest exponent in it. Okay, and my highest exponent here is 2. Okay. So I've got to include that x and that y again, because here they're both squared. That would be like having a 2 here and having a 4 here. So if you've got 2 and 4, what's your LCD? Between 2 and 4? That 4. 2 would be your GCF, 4 is your LCD. So I'm going to multiply everything by my LCD. So what I'm going to do is I am going to write this out as x squared, y squared. So I'm going to multiply everything here. X squared times y squared over 1. Okay, for my numerator, and I'm going to do that for my denominator. Okay, so in my numerator, I have x squared times y squared over 1 times 1 over x squared times y squared. X squared times y squared over 1 times 5 over x plus x squared times y squared over 1 times 2 over y, okay? I don't know if I can, how's that? Can you guys see that better? You see it okay in the back? Okay. Can you guys in the back see it okay? Okay. Now I'm going to cancel everything that I can cancel. So I have x squared, y squared, y squared. So what am I left with in the numerator? Not nothing. 1. Good, good. So I'm left with 1 in the numerator. Okay. Then I have an x, and that changes x squared to just x. Same thing happens with the y. I have y here, and then I'm changing that to y. Okay. Here, what am I left with right here? Correct. 5x times y squared. Okay, so that is this right here. That's what I'm talking about right here. Okay? And then I'm going to have plus, and what's this right here? 2. What kind of x?
Squared.
Good. Times. Good. Okay. This is really just an overview. So we're going to get into some more complex ones, but I like to start here. Okay, I like to start here because then you're exposed to it. You can think about it over the weekend. You can try a few problems. Next week, we're going to start doing them that have trinomials and binomials. So be aware that that's where we're headed. But I like to start here. So we will continue to, I guess it's raining. Well, that's cool. So I like to start here so that you can kind of be aware of what's going on. So don't miss class the week after spring break, okay? Because we're going to continue with all of these things. Definitely don't miss class. Okay.